Hello children, good morning. So children, in our last lecture we have started a new lesson number 11, reflection of light. And we have studied the types of mirror, that is plane mirror and spherical mirror. We have also studied the characteristics of the image formed by plane mirror. The types of spherical mirrors are concave mirrors and convex mirrors. And we have also studied the terms related to spherical mirrors. So children, now today we will be learning how to draw the reflected rays. Now look at this diagram. How do we determine the direction that an incident ray will take after reflection from a spherical mirror? Now in this figure, Mn is a spherical mirror and ray AQ is incident on it. CQ is a radius and therefore it is perpendicular to the mirror at point Q. Okay, now angle AQC is the angle of incidence, isn't it? And according to the laws of reflection, angle of incidence and angle of reflection are of the same measure. This we have learnt in our previous standards. So, while drawing the reflected ray QB, angle CQB must be equal to angle AQC. Got it, children? Now we can study the images produced by spherical mirrors by drawing a ray diagram. To draw a ray diagram, we need to follow some rules which are based on laws of reflection of light. So there are basically 3 rules for drawing ray diagram. Let's see rule number 1. If an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Now look at this picture, children. The blue line indicates incident ray and the pink line indicates reflected ray. Now the incident ray is parallel to the principal axis and it gets reflected when it is passing through the principal focus. Now rule number 2. If an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. Here the incident ray is blue in color and reflected ray is in pink. Now if an incident ray, it is passing through the principal focus of the mirror, that is point F. So the reflected ray is parallel to the principal axis. Are you getting me? Good. Now rule number 3. If an incident ray passes through the center of curvature of the mirror, the reflected ray traces the same path back. Now here the incident ray is passing through the center of curvature C of the mirror. So what is happening? The reflected ray traces the same path. It is getting reflected on the same path. So this is rule number 3. So children, there are 3 rules for drawing ray diagram. I hope it is clear, the rules of drawing the ray diagram. Okay, now moving to the next. So children, we have already seen the characteristics of the image formed by a plane mirror. The image size and the object size are always equal. The image distance from the mirror is equal to the object distance from the mirror. Image follows left-right reversal. That means if you are standing in front of the mirror, raising your right hand, the image will show the left hand, and vice versa. The images formed is virtual. So these are the characteristics of image formed by the plane mirror. Now let's see the images formed by concave mirror. Do they have the same characteristics, children, as of plane mirror? You all must have seen your reflection of your face in a spoon. A spoon has two curved surfaces, one curved inside and the other curved outside. However, it is not perfectly spherical. For ease of understanding, we can just consider the reflecting surface which is curved inside as a concave mirror. I will show you how the image appears by using an actual concave mirror and not a spoon. So let's find out the properties of an image formed by concave mirror. I will show you two views of the mirror. The front view and the side view. The side view is just to show you the different position where the object is kept, as it is difficult to do that in the front view. Okay, so let's begin. So let P be its pole, C be the center of curvature, and this line is the principal axis, and F is the principal focus, also called focal point. Assume that initially the object is kept closed to the mirror. Now what I'll do is I'll make a table on the right with 3 columns telling us where the object is kept, the size of the image and the nature of the image, that is whether the image is virtual or real. Okay? So initially the position of the object is between P and F. So what is the size of the image? We see the reflection in the concave mirror and the image is bigger in size. We see that it is enlarged. The dimensions of the image are greater than the dimensions of the object. So we say when the object is between P and F, the image formed is enlarged. Also, is the image upright or erect? Yes, children. And what about the nature of the image? Is it real or virtual? Yes, it's the virtual image. It appears to be formed behind the mirror. Now, where is the location of the image? It is a virtual image. So, it does not have any location. It only appears to be formed in a location behind the mirror. Now let's move the object away from the mirror. And see what happens. How the dimension and the nature of the image vary relative to the object. You will find that as I move the object away, its image gets even bigger. And when the object is at the principal focus, the image is huge. We say that when the object is at the principal focus, the image is highly enlarged. Is it a real or virtual image? It is a real image. Since it is a real image, it is upside down, or in other words, inverted. It is formed on the same side of the mirror, and at the object is, and believe it or not, the image formed is at infinitely far away. When I start moving the object away from the focal point towards point C, the image is still large, but the size is reducing. So what is the nature of the image? Here as well, the image is upside down. So it's a real image. Now children, when the object is at point C, the image is still real and inverted. But now, the size of the object and its image is of the same size. Yes, at this point, both the object and the image are of same size. What next? If I move this object beyond point C, the image remains real and inverted. But now the image of the object is smaller compared to the size of the object. So we say that the size of the object is diminished. This is also a real image. As the object keeps moving beyond C, the size of the object keeps on reducing. Now children, tell me, what if the object is placed at infinity? So, if the object is placed at infinity far away from the principal axis, all the rays form, it can be thought of as traveling parallel to each other, and after reflecting, they all will convert at the focus, and the image of that infinitely far away object will be formed at this point. Yes, this is a point size image. It is a highly diminished image and is also a real image. Now observe this table carefully, and these are the properties of the images formed by concave mirror. From this table, you can observe that the images is virtual only when the object is kept between P and F, that is pole and focal point, right? And otherwise the image formed is real and inverted. I hope you all have understood, children. Let us quickly have a look what we have studied today. We have studied the rules for drawing the ray diagrams. There are 3 rules for drawing the ray diagrams which we have learned today. And also we have learned about the images formed by the concave mirrors when the object is kept at different positions, like between pole and focus, at the focus, between focus and center of curvature, beyond the center of curvature, and at a very large or infinite distance. So with this, we have come to an end of today's session. I hope you all have understood today's topic, children. So, see you in the next video. Till then, take care.